search is a system problem. You need ingestion, indexing, query understanding, retrieval, and re-ranking. You have databases and AI, nowadays also LLMs, and everything has trade-offs. Relevancy versus latency, accuracy versus speed, query time versus indexing time. Today, we are taking a system level perspective on search, and we are talking to Stuart and Ross Cam. They have both led search infrastructure teams, first at Elastic, then at Canva, and now at their own shop. You get to peek behind the curtains of some of the biggest search platforms and learn what you can use in your own. They have seen what breaks, what scales, and most importantly, what actually works. From query understanding to evaluation systems, we will actually look at the practical solutions to the problems you will encounter in your search system. Let's do.
It's quite interesting to see, obviously, Elasticsearch, Lucene based, obviously, full text search is its core, right? That was flying that flag for many years, and then it was only later was vector added. And it's quite interesting to see the vector databases come in much later, and they're now adding all of the BM25 full text search. I think there's an acknowledgement that maybe there isn't one approach that solves all. That hybrid approach is often the best way to go. And it's interesting to see that they're both fighting or working towards the same end output. It's just the way the approach was different. That's been quite interesting to see. You're going to run the vector database as like a sidecar process to the main process, right? You are delegating all of your vector search to that sidecar. There are downsides to that, obviously. Now you're out of process. You've got something that isn't part of the core process that you have to manage. If things go wrong in that space, it can fail in weird and wonderful ways that you might not be fully aware of if everything was running in the JVM. You have a disconnect there, which is interesting. You obviously pay the marshalling cost across processes as well. There's pluses and negatives for all things, right? I guess one of the pluses is that you can access essentially unlimited memory on the server, which with the JVM is a bit more tricky to do.
I was going to say there's some historical reasons for that too with OpenSearch. So you have, I think Vice was the first one that was originally supported, and then support for NMSlib came in, and then eventually when OpenSearch 2 moved to Lucene 9, then had the Lucene vector implementation available as well. So you got 3 different choices for, I think, largely for historical reasons, different kinds of pros and cons to them, as Stu alluded to there. Yeah, it's not super clear which one to use in which scenario from reading the documentation. But yeah, some of them have limitations on things like filtering, for example, that other ones don't.
Yeah. Do you think we will see in regular search databases the same push we see in the other database types, that you have open table formats on top of S3 or GCPs on top of buckets, in which we can dump more and more onto the disk itself, and then we have indexes for text search on disk as well?
Yeah, that split of storage and compute, I think, is something that lots of vendors are starting to do more and more, in the sense that you can split out the indexing process, dump to some cheap storage like S3, and then spin up processes on demand to go and load that into memory, into efficient data structures, and then go and query on that. I think Elastic, OpenSearch have offerings that do that.
Elasticsearch obviously has searchable snapshots, which is essentially what you're suggesting there, where if you have data that's in your cold or frozen tier, you can just dump that out to S3 and have that searchable. There are downsides to that, of course. When you get into the idea of mutability, that's an issue. Often these things are better if they're immutable because they're read-only. It allows much more efficient storage. As soon as you make anything mutable, it's a bit of an issue. The other thing is obviously latency as well. Often it's the case that if something is on a disk-based system and not necessarily in memory, that there's a seek time there and a random access time that can be a couple of orders of magnitude slower than just a memory pointer read. So there's no free lunch there. You might be able to store more data, but often it's slower to access. And often you pay the price in the fact that you can't actually change it. Suitable for some use cases, not for others. Logs and metrics is probably fine. Application search, not so much.
Yeah, I think that's a good point there. If you're dealing with large volumes of data, that kind of split of compute and storage is something you typically want to do. Like for logging systems, you have a massive long tail of older information that you maybe want to query at some point in time, but most of the useful information, like the last day, 7 days. And so you want it around to be able to query it, but it's not super important to have it loaded into RAM, super fast, accessible. Whereas I think for a lot of search systems, the size of data that you're dealing with is usually typically one that can fit in a reasonable size distributed system. And having that in RAM and accessible is really what you want in that situation to keep latencies down.
Yeah, I think that's one issue also in AI that we have frequently, that you have multiple different systems in the end, which you have to orchestrate, where you have the data for training, which is in some form of offline storage. And then you have the feature store, which is more the online storage. What would you say is like the biggest mistake company making when they build their search systems?
Good question. I'll kick off on one thing. I think there's often an overemphasis on technology and not necessarily the user experience. Sometimes it's the wrong technology as well, trying to shoehorn in a database system that perhaps isn't the best for search. The first thing that comes to mind immediately is something like SQL. Trying to use SQL for search is okay. And then at some point it just falls over as you realize it isn't really designed for that. Think of doing like edge engrams or any kind of text analysis processing. SQL doesn't have those kind of features available. So often we see the wrong technology and then focusing on the technology and not necessarily the user experience as well. Perhaps Russ, you have some other insights as well.
Yeah, I was just going to say on that point about relational databases, lots of them obviously have an extension piece that allows you to do some form of full text search. And that often is like a good stepping stone, I think, into building that kind of capability in a system, particularly if you don't have any search system already there. I think what I've typically seen in the past, though, is you do start to rub up against lack of capabilities and lack of features to be able to actually implement the things that you want to. So typically, for example, one of the things that you usually end up running up against is the ability to actually configure and control relevancy effectively and the ranking algorithm used for that. That's something many years ago trying to do with SQL Server's full text search capabilities was a real hard challenge. But I think they're a good stepping stone to utilizing a specific search engine for the job. But yeah, overemphasis on technology is probably a good one. I think one of the other things that we often see is lack of ongoing evaluation. Quite easy if you follow the guidelines of many of the documentation for getting started with Elasticsearch or OpenSearch or Vespa. You can go spin up a search service very quickly, start using that, start getting some results out of there. You show it to your bosses and show it to the rest of the team and it's, hey, we have some search system up and running. Awesome. Then how do you go from that to understanding whether you're improving, making search better, making relevance worse? What's the feedback loop and the measurements looking like for that system? I think often you see that companies get to that first step, which is I've built a search system. Yes, okay, now how do you evaluate that? How do you understand whether you're making improvements to it, whether you're making things better or worse? Oftentimes, I see people stop at that point or look at trying to do optimizations in the small. So looking at specific queries that might get reported by end users or by the boss to say, hey, I went to go looking for some socks and I couldn't find any specific socks I was looking for. So then people tend to focus on the small individual issues that come up, and that then can affect the wider relevancy problem.
Yeah, I was going to say lack of systems around relevancy and being driven by anecdotes. And it's quite easy to end up in local maxima, whereby you improve a query for one set and then you end up destroying it for another set. So you end up fixing one set of queries to improve the results in one space and having them actually detrimentally affect it in another. And if you don't have a systematized approach to measuring your improvements to relevancy, often it's the case that you'll release something, you'll actually break it somewhere else and not realize that until you get a user reporting the issue. And we see that quite often, not having decent feedback loops from users, but then also not having the necessary system in place to release those improvements or perceived improvements to relevancy. So yeah, that's poor handling of edge cases, variability, that kind of thing.
How do you approach that when you really have a system in production already? You have a small test set. Do you basically add more and more examples for the different edge cases you encounter to the test sets over time until you say, I have a broad coverage of the different query types and the results I want?
Yeah, so there are a number of ways to do that. So, like a golden query set is a good place to start, which is if you think about the what you would like to do with a golden query set, you're trying to establish a sample of queries that users run on your system that encapsulates a proportion of the head queries. So those queries that are the most popular. So that might be, if you're on a retail site, it might be an iPhone, iPod, etc. And then you would want to have a representation of your middle queries, so things that aren't necessarily at the head or tail, but it's a broad set of queries. And then you'd want a sample of tail queries as well. So you want a broad sample of everything. And you would essentially then build up a golden query set, which is for those queries, what are the human evaluated set of results that best fit that query? That would essentially then be a human list, a human judgment list. So you'd have your operators go in and say, if I was searching for X, Y, Z, I would expect to see A, B, C, and these products. That allows you essentially then to establish some kind of baseline for if you change an algorithm in your search system, or if you change your search system, are you still seeing for that golden set? Are you still seeing those results in the same position? Or what if you're not, what is the deviation? And there's all sorts of mathematical functions out there, for example, NDCG or reciprocal rank, that allow you to work out should we say, a mathematical figure on the change delta between the two algorithms. And that essentially then buys you some level of confidence. And it gives you a line of inquiry as well. If you change your algorithm that affects head queries positively, but tail queries negatively, you might say, actually, we're okay with that. We're happy to improve it for the head queries, but not necessarily for the tail queries. Then you might establish a new baseline and measure from that instead. But at least it gives you a line of inquiry. Now, we would see that essentially running in an automation suite. So when you make a change, your new algorithm is run against that automation suite, and then you get the results back, and then you can establish whether or not you think it's a viable change. And then once you believe it's a viable change, then you have a number of avenues available to you in terms of, okay, we think this is an improvement. That opens a question of how do you establish that it's an improvement? So what are you going to measure against? No, you could, for example, if you're an e-commerce store, you could measure against number of items that are bought or number of items that are added to basket or some kind of business metric. And you could track based on the search, what are the improvements to that underlying business metric? And then, so what are you going to measure against? And then how are you going to measure it, or how are you going to deploy it? Then you get into aspects like A/B testing. So segregating users up into different groups and essentially giving them a different algorithm and then measuring the results of that group. Or if you find, for example, with some tail queries, because you often don't get enough traffic on those tail queries, then you can look at other methods like interleaving, which is essentially running two algorithms at the same time and interleaving the results, and then essentially trying to then work out based on the interleaved result set what was the net effect of each algorithm. So there are a bunch of ways to measure your improvements or perceived improvements to search, and then obviously you want rollback mechanisms and that kind of thing in case you made a mistake. So
It's
And
maybe worth pointing out as well the sort of the bias of human nature here, in that people tend to report things that are wrong in some way. And so back to your point that you asked, which was, would you add these bad results to a collection of queries? Yeah, you can totally do that. I think that is something that every place I've seen does. But yeah, there is the element of bias there, that in the sense that people, like, for example, when people are reviewing things, people tend to write negative reviews for things, but they don't often write positive reviews for things. So there's a natural human bias there to report things that are bad over things that are necessarily good.
And when you're running these test suites, I imagine you're not running it against a production database. How do you set it up in the background? Does every search engineer have its own development database, which has a copy of the production database or a copy of a small set of data of the production database?
that's a good, I mean, it's obviously it's environment dependent, right? But the best case scenario is you are running against a production data set. That's the best case scenario. In some instances, you're talking about having, I hate the word, like a backdoor or some kind of other mechanism into the search system where you can run your evaluation tests. The quality of the data, it's often the case in corporations that the production data is as the gold standard, and it's polished, it's maintained, it's true, if you like. And then it's often the case that the precursor environments, say pre-production or test or development, it's often the case that the data in those environments isn't as good ultimately. And many reasons for that. Cost is one, your maintenance is another. There's all sorts of reasons why that's the case. So if you're not running the algorithms on production-like data, there's a danger that you're now evaluating the algorithm against something that's inconsistent with production. You want to run it against production data. Ideally, you'd like to run it in the production environment. So usually that's a case of negotiating with your DevOps team about trying to find a way of having this sidecar of the evaluation process running. The one thing I would say with that evaluation process, you're potentially talking about running tens of thousands of queries. So try not to denial of service your own system in the process. You might want to have some kind of staggered approach to running those queries. I've certainly seen servers get very warm from when the evaluation process is running. So try not to do that. But yeah, you
Yeah.
want to run it in the production system, basically.
Yeah, there's maybe something else to add there. Yeah, if you really want to be running against what is in prod, because yeah, staging, dev usually are not the same. If you can mirror prod as well, that have a real-time mirror of the production system, that's also good as well. The reason why is oftentimes you do want to run evaluations where you, say, for example, want to return more debug information or more explain information back from the system. And so that can put large additional strain on the production system. And so if you can offload that and manage that separately on a mirror, that's much better.
Yeah, that's a good call out, Russ. For example, if you use explain equals true with Elasticsearch, brace yourself for the wall of text that comes back, and all of that's obviously memory allocated on the server. Yeah, that's a fair call to push towards a mirrored system.
Yeah, or profiling queries is another one that's just super expensive to do.
I think the additional complexity in search, you have so many different interleaved components. Let's maybe move into that. What are the main components when you look at a search system? What are the main architectural components you have to have in place? And whether that's like actual infrastructure or business logic or actually processes that have to be in place.
Really good question. A good question. Look, I think it's always, I hate to say this, but it depends. Like it does depend on what it is you're trying to do. If we were to pull up an example from what we were speaking about before, a very simple search system could literally be something like a query string query on Elasticsearch, where you're taking the user input without any processing whatsoever and passing it into Elasticsearch and hoping for the best. That is like the, shall we say, the minimum required architecture. Now that's going to get
Can
you.
I just jump in there a second?
Go on, Russ.
You'd quickly want to move from query string query onto simple query string query so that any syntax problems in the query don't take down the server.
So that would be your step 1.1, definitely. That's your sort of super simple. I would say that's virtually no architecture. Essentially, you're just passing the raw string input in. But as you become, there are, should we say, well-known hurdles that you would want to, that you end up having to jump through in order to conduct a search. Now, a lot of this is use case dependent, and there's no, I don't know if there's an architecture that suits all types of search, because there's a big difference, for example, between a search system that has, you know, like maybe 2 or 3 keywords versus a search system where users are entering in, say, full paragraphs of text. So there are very different, and that's not even getting into multimodal, for example, where people are searching on images or on video. So there's no one size fits all. I think it's probably worth just constraining it to, say, for example, full text search, because that's what a lot of search systems are that are out there at the moment. What are some of the components that we see in search systems? If you said at the beginning the user types in their query, that's like the user query essentially. So then you think about, okay, what do we know about that piece of text? You may want to rewrite it, for example. You might want to maybe, I know, standardize the case for it, make it all lowercase, for example. You might want to remove weird and wonderful punctuation. You might want to strip out all of the emojis and all of the other crazy stuff that's put in there. You might not want to either. You might want to leave that in there. So you'd want to essentially think about rewriting that query. So user query comes in and you rewrite it in some way. What does that rewrite look like? Do you have different types of rewrites? Do you make it completely opaque? Everything that happens after that rewrite is it's just a one-time transformation, and you lose the history of what's happened prior to that rewrite. Is it a rewrite where you could maybe see the history of rewrites that have happened? Is it a forked rewrite? So now I type in, say, I search for iPhone. What does that get forked into? Apple iPhone, mobile phone? Does it become multiple different things? Do each one of those multiple rewrites then start their own search? Rewriting is one thing that we see. Tokenization is related to rewriting, which is given a sequence of characters. How do you atomize that into a series of other components that then make sense? And there are edge cases to this. For example, if I search for seat belts and I put a space in there, am I searching for seats and belts? Probably not. I'm probably searching for seat belts. So there are edge cases to rewrites that you need to think about, and that will be corpus dependent as well. So your corpus and what you're having people search over will inform you some of your tokenization rules. You might want to do white space tokenization. You might want to factor in noun phrases. You might want to look for common kind of word forms that go together. Seatbelts is one example there. So you have tokenization, and this is really just before you even get to the search engine in some instances, because you have your own data sets that you can refer to. So essentially it's like text manipulation that happens prior to running your search.
If we were
Instead of all like one bracket, basically like the query understanding part, which is its own service, which is basically just doing all the pre-processing on the live queries that are coming in.
Yes, yeah, this all fits under that umbrella. It's of query understanding. Russ is desperate to talk, so I'll hand over.
Yeah, if we took a step back for a second and we just talked about what are the big parts of any search system that you have. You have ingestion, indexing, which could be as simple as some kind of bulk overnight import process, or Could be some event stream based, Kafka queue based mechanism to stream in changes from your underlying source of truth data into the search system. That ingestion and indexing can be somewhat simple. You could go with defaults. It could be vastly complicated. It could incorporate all sorts of different signals into there that need to be indexed into the search engine. And then the next sort of big layer, as Stu was touching on there, is obviously querying and what happens at query time in the search pipeline, and query understanding phase, retrieval phase, ranking phase, etc. And then the other sort of big parts are analytics, where you're capturing metrics and feedback on the data that you're showing to people. So things like clicks, click streams, that kind of information, what rank in search results that you're showing that users are clicking on, all of that sort of, I would say, very voluminous data that you typically want to capture and then build models on top of. And then, evaluation. So putting that data that you're capturing into motion and into practice to build some better systems that you can then incorporate into that query search pipeline side of things. Those are kind of like the big key components, I would say. There's a few other ones. So from a systems perspective, obviously operational resilience of that system is super, super important. But then, interpretability, understandability, or explainability for the results that are being shown, having some kind of provenance for the results that you're seeing, particularly if you're pulling them from multiple different data sources, or there may be multiple different rankers involved within a pipeline that are happening in stage. How did this search result actually end up appearing in here for this given user? Can I clearly explain exactly what happened in each component to understand how the results were the way they were?
That's a much better, broader answer than I gave, Russ, because I jumped straight into the first part of query understanding. So thank you for taking a 30,000-foot view there.
And when I'm looking at the system, I think there are so many implementation details, even just for indexing. I think like what you mentioned, like you can have a batch workload, you can have a stream that's coming in at the same time, but underneath it in vector databases, it's now common that you basically have two separate ones. One is the already indexed data, and one is basically the data that's coming in live, just because the indexing time is so long that you can't really use the inserted documents in the search immediately, so you have them in a separate storage. What are like the decision factors you're considering when you're setting up a search system, like when you're looking at all the different components you have, and you basically have to decide like what to go with for each step? What is coming into play here? Is it mainly the user behavior? Is it the type of documents that's being searched, or the types of search, whether that's multimodal, full text, vector?
It's a good question. It's a good question. I think the way how it's often been described in terms, so if we take, say, for example, a company wants to do search, or they want to improve their search, usually there's a set of functional and non-functional requirements, right? So a functional requirement, it would be something like, we have X billion documents or X million documents, and they change on this cadence, and they look a certain ways. So maybe they have a certain weight to them, a certain number of kilobytes or megabytes or whatever the thing is. So that usually is like a description of, should we say, the corpus size and its changeability. So that's usually one thing that's described. Hot off the heels of that is usually we want searches to happen within X milliseconds or X seconds, let's say. Usually it's in the milliseconds, and usually it's under 100. So given a search query, we expect a set of results back in this amount of time. So corpus size, expectations around search latency are often there. And then cost is usually a factor as well. We don't want it to cost X amount of money. So those are the three kind of highlights that are often presented. Now, in terms of what's feasible or possible then, We would essentially work out what's the most appropriate architecture. And sometimes there's no free lunch in all of this. Often it's a case that to service billions of documents on a vector search, less than 10 millis, you can do those kind of things. They're just incredibly expensive. It's really about trying to manage all of the overall system to find what is an acceptable balance. So it's either going to come down to speed, cost, or corpus size. That's usually how these things play out.
Yeah, I think that's a good point, is you really need to understand the requirements of the pain points you're trying to solve. I think you need to understand the constraints of the environment that you might be working in as well. So, for example, building a search system for a small company doesn't have dedicated search engineers, has perhaps a few engineers that are looking after everything, well-rounded, but looking after everything. What's the most appropriate thing to build here that when they're looking for some search capability? Now, that's obviously very different to a larger company where search is absolute paramount to the user experience of their system. Yeah, and there's very likely to be dedicated search engineers, machine learning engineers, data scientists working together on trying to solve problems collectively. What fits for that is going to look very different to that first case. And then, yeah, the sort of technologies and techniques that you might be looking at might be quite different too. There might be a tendency, for example, in that first case, to look at systems that you can buy and get relatively far with off the shelf versus investing a lot of time in building out more complicated but componentizable systems that allow you to experiment with different components and different parts of the system over time. Yeah, it's the old adage. It really depends.
And to make it a little bit explicit, we've talked before about the different trade-offs you can do. Can you maybe go into the main trade-offs you're considering? Because I think for a search system, it's worth it in the beginning to make them all explicit. For example, cost. Is it like I can maximize on performance of the search system, but it will just become prohibitively expensive?
Yep. So, I mean, there's a few kind of trade-offs that you can make. Relevance and performance is one. So, what do you care about more? Do you care more about the performance of the search versus the accuracy and relevancy? For example, with some ANN queries, you can essentially bake in your retrieval characteristics of like how much performance versus accuracy that you'd like. What's important to you there? The next one I think is indexing versus querying. There is often the case, indexing and querying are like two sides of the same coin, essentially. And I've seen examples where to improve the search, you would change the indexing. Instead of improving, for example, the query itself, you would actually add an additional set of, shall we say, pre-processing or other algorithmic changes in your indexing that then allow that data that's already pre-computed to then go into the search engine, which can then be used to query time. Now, the downside of that is essentially now you're baking in that computation into the indexing stage. So if you want to change your query, it's often the case that, okay, well, now you have to go back to the beginning and re-index all of your data using a slightly different form. So that's often a trade-off that can be made. It's often the case that trying to run an algorithm, for example, at query time is often slower than if it's been pre-computed in indexing. So that's a trade-off that happens quite regularly. I'll hand over to Russ for a couple of other trade-offs that we've seen.
Yeah, I think that's one of them, pre-computing features or signals at index time versus query time. That's a classic trade-off between the two. Indexing usually faster, querying more flexible and can change them more on the fly, but typically result in slower searches. I think that kind of touches on a wider point, which is there is a balance here between the latency of search results that you're trying to hit and the level of complexity or personalization or query understanding that you might decide to go into in a search pipeline to be able to improve the results. Can often be a balance and a trade-off between those. You might have, for example, an algorithm or a way that has, you can demonstrably show massively improves the results, but if it's going to take 3 seconds for every single person, it's going to be unfeasible. So there is that trade-off to make there too. There are ways of building into the system around resiliency and hang off after a certain point where you can try and build that stuff in. But yeah, that's typically one of the other trade-offs you often see.
And that's, I think, the current trend, especially because most people are building RAG systems in a way that the search is very crude. So you have to actually add stuff that can increase the relevancy for the user in the end. So you have to have a re-ranking component, which is very costly, especially looking at if you're doing something like Colbert.
Yes, yeah, exactly. It's the old adage of garbage in, garbage out, in the fact that you want your retrieval phase to surface the most relevant results it possibly can. But there is a trade-off there in terms of how much you can feasibly do or what signals might be available en masse to be able to do that for all of your users at the retrieval phase. So then often, you would want to employ more complex but better ranking mechanisms in a post-retrieval ranking phase that allows you then to finesse and fine-tune those results that come back from the retrieval phase.
Yeah.
But you want to make sure that you still try and get in that bucket back from the retrieval phase the very best results that you can in order for ranking to be able to do a better job.
That's right. You can only re-rank the results that you've been given to re-rank. So if the gold nugget isn't in that initial set, then it's never going to make its way to the top, regardless of what re-rankers you have in place. And that is in itself is a trade-off. And re-ranking is often used for tying in personalization or machine learning models that are inherently just difficult to host within a search system. They're excellent for that, but yeah, as I said, you can only rank what you've been given. So if you don't have it, you're not going to re-rank it. And that's interesting because that we've seen approaches whereby, if you, for example, need to serve 100 results to a user, do you think about overfetching, say, 300-400 results from your retrieval system and then running that through a re-ranking so that of the 300-400, at least you're giving more information to the re-ranker so that at least then the top 100 is, well, in theory, it's the top 100 out of 400, as opposed to the top 100 just simply reordered. There are approaches for overfetching where you can hack some of that. That does make paging very interesting as soon as you start doing overfetching, but that's one approach to potentially get around some issues there.
Yeah, and when you're looking at you're coming into a new search project, you're coming in. Do you have a set of questions you're asking the people or you're asking yourself to run through to basically figure out the requirements you're facing in that particular system?
Yes, they're usually scattered and numerous. I think the top three for me are usually along the lines of how big is the corpus? Where does the data come from? What's the source of truth in your environment? What is the feed into this search system? Because there's often usually not just one system. Often it's an accumulation of multiple different systems. So what is feeding it? How big? How many documents? Size of documents? Expectations around latency? Where does data governance fit in as well? This is usually something that crops up. The search systems inherently, there's a tendency for them to attract everything in. They can become like hubs. You've got, say, for example, 5 different departments, and the combination of those 5 different departments' information all has to go into the search system for some reason. So now your search system is essentially the master of those 5 pieces of those 5 departments, right? And then you end up with interesting questions. Who actually now owns that data? Is that the search team? Are the search team now responsible for the hygiene, cleanliness, etc. of that data, or are the individual departments? And how do you manage changes and expectations of changes? What happens with the data? So governance is one that comes up quite often. And yeah, usually things like what cloud providers are they using? What are their expectations around DevOps? What do their number of developers look like? What the languages are they using? So it's a kind of the broad set of key questions that you might ask, plus then all of the search questions that you would ask as well.
Yeah, I would say one of the key questions for me is, and we touched on this earlier, is how are you currently evaluating the system that you have? Because we need, in order to be able to improve a system, we need some forms of measure to work against. And so, do you currently have a system in place that you're able to point towards and say, yeah, we can see that this is where we're tracking for this stuff. These are some North Star metrics that we have for things. Do they have that system in place already? Or is that something that they've thought about? And again, are they doing in the small? Or is that something that also needs to be built as a precursor to looking at improvements in the search system?
How often is it the case that you actually have a eval set already set up?
It
Fairly
varies.
it varies fairly frequently. There might be different cases where it's maybe not being used effectively, or in a format where, say, the data is being collected, but it's not really being put to use effectively. That's fairly common.
It's quite common to see KPI metrics around general business activity, but then not see that tied up to search. So we're tracking the amount of inventory we're selling, we're tracking page views, but we're not associating it to a search in some way. So often it's a case of actually, if you can tie this up to user behavior around the search, now you have the complete path available to you. You either see fragments where they're half collecting or not at all, I would say. And those are the two common scenarios. It's rare to see proper evaluation done, I would say, in most places. That's where we do see a lack.
I think that's a good point that you touch on there, Stu, is that if you're able to tie in changes or uplift in the search system to the core underlying business metrics, it's very easy then to make cases, or easier, I should say, to make cases for further investment and improvements in those systems. Because ultimately that is the goal of any of these improvements that you're making, is you're ultimately trying to uplift the business value that you're getting from these systems. And so if you have a clear case of being able to tie those things to say, hey, this algorithmic change that I've made here, I've run it through offline evaluation, I can show that it results in a 5% improvement, or even a 2% improvement, or even less than that. But if I take that to interleaving or an A/B test, that can result in X amount of uplift for the business, for the company over the year. I think it's good to get into that kind of mindset of thinking when you're looking at improvements.
Yeah, I would say actually that's an interesting thing you bring up there, Russ, which is around delta differences that you can see in improving search. It's not uncommon to see like in the single digit percentage improvements. So, you might see a 1-2% uplift. So you have to think about, as you go through your search journey, if you like, you might find that there are some very quick wins. You might get your 10-20% improvement and everybody's high-fiving, like we're really improving this thing. And then you might see that diminish. Okay, so you might see it getting into the 1%. You might even see, actually, I would say a good marker of a sophisticated system is one where you actually see it's getting worse, because if it's getting worse in some ways, you might be at some point of maxima, right? You might be discovering a maxima. Yeah, it's compounding effects essentially over time is what you're interested in. 1%, a 1% improvement over 50 improvements is still quite a significant change.
Yeah, and if you have some versioning to these algorithmic changes that you're making, even better, because then you can look historically at these changes that you've made and determine how you've ended up and landed into this weird, complex, convoluted query and ranking system that you have now, how and why you've ended up in that situation. But yeah, to your point, Stuart, is very much does follow like a Pareto principle, like 80% you can get is 80% of the work is down to 20% of the improvements.
And I always like to go into that in the end, like overrated, underrated. In search, especially, what are things that are overrated and what are things that are underrated to do?
I'm going to go out on a limb here, which is always risky to do on a podcast. But I think that there's obviously a lot of hype around, for good reason, around vector search, similarity search, RAG-based systems. I think that what we are seeing is that none of these are going to replace full text search. I think what I've typically seen over time is that actually more and more places that may have initially jumped on a RAG vector based approach to things, which isn't necessarily suited for all kinds of searches, but over time that they've ended up actually taking more of a hybrid approach, because the full text search side of things brings things there that a vector based approach isn't as effective as a full text approach is. So, for example, if you want to find search results that exactly match the keywords that are being put in there, full text search is perfectly good at doing that. Yeah, so I think I don't see things as being necessarily a replacement. It's a hybrid approach and a combination of approaches that we're seeing happening here.
Yeah, I think I'm pleased that you've gone out on the limb there, Russ, because I was going to go out on the same limb, but I think I would echo what Russ has said there. Is vector search it definitely has its place. I think it might be suffering from the shiny thing out there, so everybody's flocking to it. But I still think that plenty of mileage that can be covered by just improving your full text search. And there's an argument to say that in many instances we've seen that's actually easier than taking on a vector-based approach, which often requires machine learning skills. They have a machine learning hosting problem. You have a whole index and ingest problem there as well. You have all the costs associated to it. Whereas actually all you really needed to do was change a few lines in your text processing. We've seen instances like that. I would say underrated, and I did go off on my 30-foot view on rewriting and tokenization earlier, but I would say underrated is definitely query understanding, which is failing to properly understand what the user intended through their search and failing to essentially translate what they had entered into a meaningful search query. That's definitely underrated. So,
Yeah, I think it's going to say on that point, I think I think some of it goes back to when you start to build out a search system and what things you start to put in place, and you build up a more complicated architecture over time. It's very typical to take the user query verbatim, do no query understanding on it, pass it to the search engine, get the results back, serve them back to the user, then start to maybe perhaps introduce some form of post-retrieval ranking in there, perhaps for personalization, and then to build out these layers. But that whole sort of query understanding phase and trying to better understand user intent, I think, is something that is often undervalued from what we've seen.
Yeah, and if people want to improve the search system and get in touch with you and follow along with you in general, where can they do that?
So they can reach us. So Russ and I both have a consulting company called Search Pioneer. So we're available at www.searchpioneer.com, and we're also reachable on LinkedIn under the same name, Search Pioneer. So either of those is the best way to get in contact. If you go to the site, there's a form. You can read about clients that we've interacted with and some of the success stories and what we're all about. And if that's something that interests you and you believe we can help, then get in contact and we can discuss your situation and hopefully see if we're able to help you.
Okay, what can we take away? I think what I'm always interested in first is actually how they make decisions and what are their frameworks of how they actually think through the problems I want to solve. And I think their core constraints for search infrastructure are very interesting. So they had corpus size, latency requirements, cost limitations, but also data governance needs. And I think these are interesting guardrails to basically come up with an architecture. And the fact that there is no free lunch, and that you actually really have to think through, like, what are you optimizing for? And this should also be informed by some kind of business metrics or performance metrics that go beyond your search systems, and actually the search metrics or the performance metrics like latency that you actually can measure in your system. And the trade-offs often come very early, that you have to decide when you actually optimize. So for example, you can incorporate a lot of stuff at indexing time, but then you can't really adapt at query time, which often limits how relevant you can make a search results if you only bank on the information you have available at indexing time, because you have less user information, so you can do less personalization, for example. And I think the relevance versus performance trade-off is probably one of the most interesting and important ones you have to actually consider. The main architectural components they broke down, they basically had the ingestion versus indexing, then you have the search pipeline, and then you have like the analytics or the feedback loop. And the search pipeline you could basically break down into three separate components. First, query understanding, which is often its own pipeline. Then the retrieval component, which is actually the interaction with whatever search database you're using. And then lastly, your re-ranking component, which re-ranks all the search results and prioritizes them, or does fusion if you have multiple different search databases. They had basically three different validation approaches or a 3-layer testing strategy, which was first a golden query set, which basically covers head, mid, and tail queries. Then you have your basically automated evaluation suite, which builds on these queries with MECG, reciprocal rank, or whatever you're using. And then at the end, you basically have your production A/B tests, or something like interleaving, where you have multiple algorithms and you interleave their results to evaluate the system as a whole. And I would add on top of basically the business metrics. Because when you're doing or implementing a completely new search system, you should also in e-commerce, for example, measure like, okay, what's the revenue impact? And you can never exactly measure that. Like, it's not like an A/B test where you have two different versions of a system running, but you likely have like, you go from 0 to 1 or you do a major overhaul. So you actually want to have like a view on the business metrics as well. And what surprised me a little bit was their advice that you always have to or should run your tests against production environments and not really dev or staging environments, because you need to test against production data. And I think this is partially informed by them having worked on very, very large search systems where it's actually very impractical or even infeasible to run the complete database multiple times because it's so large. So you probably can't really replicate the production system into a dev or staging environment. I think for most of us or for most of you, you work on smaller search systems, so you can likely do a complete replica and test against production data, but in a dev or staging environment. If it doesn't apply to you, go with their advice. Actually be really careful that you're not DDoSing your own service. And especially when you add stuff like the debug operations, like explain equals true in Elasticsearch, you should be really careful around those because they really increase the load or strain you're putting onto the system. Next week, we will be continuing with more on like the systems perspective on search. And I'm excited for that. So leave a like, subscribe, so you can stay notified when new episodes come out. And I will see you next week.